First up, the rope tornado. This is what a twister looks like right before it dies out. The funnel stretches and thins until it genuinely resembles a piece of rope hanging out of the sky, twisting and bending in the wind. It looks almost fragile, almost harmless. But don't be fooled by the skinny shape. Even in this dying stage, a rope tornado can still whip up dangerous winds right where it touches the ground. Next is the cone tornado. And this is basically the poster child of tornadoes. Wide up at the clouds, tapering down into a narrower point at the ground, forming that classic cone shape everyone recognizes from movies and storm chaser footage. This shape usually means the storm feeding it is strong, organized, and has been building up a lot of energy. Then things get a little strange with the anticyclonic tornado. Almost every tornado in the northern hemisphere spins counterclockwise. It's basically the rule, but every so often, one comes along that spins the completely opposite direction, clockwise, breaking that rule entirely. These anticyclonic tornadoes are rare, and they usually show up as a smaller companion twister, riding alongside a bigger normal one. Speaking of companions, that brings us to the satellite tornado. This one is exactly what it sounds like. It's a smaller tornado that actually orbits around a larger main tornado, almost like a moon circling a planet, both spinning under the same parent storm at the same time. Two separate funnels, dancing together, and it's honestly one of the more surreal things you can witness in severe weather. Now, not every tornado needs a massive, violent thunderstorm to form. That's where the cold core tornado comes in. These spin up out of weaker, cooler storm systems, often in the fall or early spring, when the atmosphere is unstable but not dramatically severe. They tend to be smaller and don't stick around for long, but they're still capable of doing real damage, and they still show up clearly on radar. And now for the one that should genuinely make you nervous, the invisible tornado. This is a tornado with no visible funnel cloud at all. There's no dramatic swirling cone reaching down from the clouds. Instead, all you see is a wall of dust and debris getting kicked up right at ground level, which means by the time you can actually see it, it's already tearing through. This is exactly why weather sirens and official warnings matter so much more than trusting your own eyes. Moving away from classic tornadoes entirely, we've got the fire whirl. Technically, this isn't a true tornado, but it earns its spot on this list because it looks like something out of a disaster film. A fire whirl forms when an intense wildfire generates so much heat that it starts spinning its own column of flame and smoke into the sky. Basically, the fire gets hot enough to create its own weather system. On the calmer end of things, there's the steam devil. These form over warm bodies of water when a blast of cold air rolls in above the surface, kicking up a swirling column of mist and vapor. They're nowhere near as dangerous as an actual tornado, but watching one drift silently across a lake at sunrise is honestly one of the eerier sights in nature. Then there's a type that sounds almost made up, the snownado, also known as a snow squall tornado. Yes, this is completely real. These form during intense snow squalls, and they're rare enough that meteorologists genuinely get excited whenever one gets officially confirmed. Picture a tornado, except the entire scene around it is a blinding wall of white. Now we get into the science nerd territory with the suction vortex. Inside some of the most violent tornadoes, there are actually smaller, even faster mini funnels spinning around inside the main one. These suction vortices are the reason you sometimes see one house completely leveled while the house right next door barely gets touched. It's the tornado within the tornado. Sometimes a single storm doesn't stop at producing just one tornado. That's the tornado family. A single supercell can spawn several tornadoes, one after another, along a similar path, sometimes stretching over hours and dozens of miles, each new tornado forming as the last one weakens and dies out. And finally, proof that you don't even need a dramatic, rotating supercell thunderstorm to get a tornado at all, the non-supercell tornado. These form from weaker updrafts, usually along a boundary, where two different winds collide and start spinning near the surface. They're typically weaker and shorter-lived than their supercell cousins, but they're a solid reminder that tornadoes can sneak up from storms that don't look severe at all.